We thank you again for attending our demo sessions on PCI Express testing. Today we talk about Gen 3 testing for transmitters, PCI Express transmitters. The compliance patterns and the test patterns as well as the requirements for testing PCI Express have evolved dramatically from Gen 2 to Gen 3, and that's due to the increased bandwidth and the nature of losses that could appear across channels, whether they're backplane channels or motherboard or add-in card channels. So today we'll talk about the compliance patterns for Gen 3 devices and how to measure them. So the setup we have today is again same as before. We have a high-end Gen 3 device connected to the SV1C testers, and we'll focus only on just the transmit port of the device for today. So to test the transmitters at Gen 3, we have to go through a toggling sequence that is very much similar to what happens in Gen 1 and Gen 2. And so we've written an automation script that's available for our users where we toggle the device to Gen 3 and then start negotiating its scrambled compliance pattern automatically. So click Run and look at the performance. And again, we're looking for compliance patterns on all 8 lanes. And so we put a pause in the test procedure here just to look at exactly what happened. The SV1C has identified the patterns on the devices, and we'll look at the result here, channels 1, 2, 3, 4, 5, 6, 7, 8. And when we look through the detected pattern, the identified pattern, we notice that the last 2 channels are swapped. So we have channel lane 7 preset 0 is attached to the previous channel, and then lane 6 preset 0 is attached to the next channel. And that's because of the swapping that we have done on the board ourselves. And so we made a mistake in connecting the cables, and we decided to show it because it illustrates the tool's ability to actually detect the missed connections. At any rate, we'll continue this way because we're only interested in signal integrity at this stage, and so we'll keep the connection running and simply start looking at the TX parameter measurements. So very much like in Gen 2, we have set up the SV1C to measure the analog waveforms as well as the bathtub plots and the eye diagrams. So the analog capture has just completed. We've gone on to perform the bathtub plot measurement, and now taking about a minute or so to measure the eye diagrams at 8 gigatransfers per second on all 8 lanes. Okay, so the test has just ended, and the tool has taken us to the result window for the device. And so we can look at the various measurements here. This is the analog waveform capture across all 8 lanes. And we have purposely set this up so that we could trigger the analog waveform at different points in the pattern. So if we look at the first channel here, the first lane, we're measuring it at a point where there's a constant sequence of zeros for a while, followed by a high frequency pattern. And the reason we show this is that typically PCI Express asks to measure voltage levels in static conditions like this. It's just a lot more accurate and a lot more consistent to measure voltages at the end of long periods of identical bits, as opposed to in varying bits as in this section here. But it's interesting to see how we could trigger the different channels to capture different sections of them. Another measurement point that's typical could be the high-end point here on the pink graph, where again, instead of measuring at the sequence of long zeros, we measure after a sequence of long ones. And so this is just a quick illustration to show how we could trigger each channel really to be independent of the others and still capture the waveform patterns progressively this way. So each channel now is triggering on its own window. And then finally, the bathtub plots here are at 8 gigabits per second, so you could see the unit interval is 125 picoseconds as opposed to 200 picoseconds. And then the eye diagrams are shown here, where you can see that, again, they're still pre-emphasized because it's one of the presets for PCI Express. One of the requirements for PCI Express is to have a preset value on the output. But we also see the eye closure and eye opening here as a function of channel. And before closing, we'll just show the compliance pattern for Gen 3, just to illustrate how different it is from from Gen 1 and Gen 2. And so it's really a scrambled pattern, and it's quite long compared to PCI Express Gen 1 and Gen 2. And so it does have certain characteristics, like some pathological sequences here that we've triggered on for the analog capture, and that's all designed to provide the most significant stress for transmitters and receivers when it comes to testing and verification. So there you have it, quick transmitter testing at Gen 3 PCI Express rates. Thank you.